All right, let's talk about complex numbers. So when we solved the equation x squared equals 7, we got two real number answers, positive and negative square root of 7. So what happens when we try to solve x squared equals negative 3? Well, you probably recall there's no real number that makes this statement true. So mathematicians had to invent an imaginary number. So x would be plus or minus the square root of negative 3, which is the square root of negative 1 times the square root of negative 3. And always remember you get two answers. So they invented a number for this, which is called I, or an imaginary number. So the solution of this equation, or the two solutions of this equation, are I square root of 3. Let's do another one. All right, if x squared is negative 25, what would x be? Well, don't forget you get two answers, plus and minus square root of negative, or principal square root of negative 25. But it turns out that 25 is a perfect square. So you get the square root of negative 1 times the principal square root of 25, which is 5. And then we just learned that this is I. So our two solutions are positive 5i and negative 5i. So if your I is multiplied by a square root, you put the I in front, otherwise it looks like it's underneath the square root symbol. But if it's with a regular number, you put it after. Let's do one more. All right, and I bet you could solve this one on your own, so you can hit the pause button and try that. All right, so take the square root of both sides. Remember, you get two answers, a plus and a minus. 9 is a perfect square. So we get 3i, and then we just add 3 to both sides. So x is 3 plus 3i. X is 3 minus 3i. So this is a complex number. Now this is the real part of your complex number. And this is the imaginary. Right. If the principal square root of negative 1 is I, then what would I squared be? Well, that's negative 1. So this is definitely a fact that you should memorize. All right, let's do some operations with complex numbers. So if you have 2 plus 7i and you add 3 plus 5i, you just add the real parts and add the complex parts. So you would just treat it the same as you would if it was 7x and 5x. You would just get 12i. right, so let's try this one. So first I would carefully distribute this minus. And then combine like terms. 3 minus 2 is 1. Negative 4i and negative 5i make negative 9i. Let's try another and keep this in mind. All right, let's simplify this expression. And if you're feeling ready, you could go ahead and try this on your own. Let's just multiply it out. 2 times 5 is 10. The outer product is 4i. The inner product is 15i. And then the lasts are 6i squared. So we can combine like terms. And anytime you have I squared, you want to use this fact to simplify it. That I squared is negative 1, so 6i squared is 6 times negative 1, so that's minus 6. Positive 10 and negative 6 make 4. All right, let's try another one of those. All right, so I would definitely try this one on your own. So 5 times 3 is 15. The outer product is minus 20i. The inner product is 6i. And then 2i times negative 4i is negative 8i squared. Combine like terms. And then you always need to simplify the I squared. So I squared is negative 1. So this is negative 8 times negative 1. So that's plus 8. And then you just add 15 and 8 to get 23. All right, let's try another. All right, if you have a rational expression with complex numbers and you have I in the denominator, you're not allowed to leave an I in the denominator. So we're going to use something called the complex conjugate. The complex conjugate of 5 plus 2i is 5 minus 2i. So it's the same parts with the middle sign changed. And we're going to multiply by a fraction that's equal to 1, which is composed of the complex conjugate over the complex conjugate. And it would probably be a good idea to put parentheses so that you remember to distribute. Two times 5 is 10. The outer product minus 4i. The inner product 15i. And then the last terms, 3i times negative 2i is negative 6i squared. The first 25, the outer product minus 10i, the inner product plus 10i, and then the last minus 4i squared. And by now you probably see why we use the complex conjugate, because the negative 10i and plus 10i will add up to 0. That's by design. And then we use the fact that I squared is equal to -1 to simplify this. 10, -4i and plus 15i make positive 11i. -6 times I squared is plus 6. -4i squared is plus 4. 16 plus 11i over 29. We have I in the numerator, that's totally fine, but we've eliminated I in the denominator. So this is the same number that we started out with because we multiplied by 1, but it's written in a simpler form with no I in the denominator. Let's try another one. All right, if I were you, I would hit pause and try this one on your own. So we have I in the denominator that we need to get rid of. So we're going to need to multiply by the complex conjugate of 3 minus 2i, which is 3 plus 2i. And in order to make this fraction equal to 1, make sure the numerator is equal to the denominator. And then distribute. 5 times 3 is 15. The outer product is 10i. The inner product is minus 9i. And then the last terms, -3i times positive 2i makes -6i squared. 3 times 3 is 9. The outer product is plus 6i. The inner product is minus 6i. And then the last, minus 4i squared. And then by design, these middle terms add up to 0. We get 15. 10i minus 9i just makes plus I. -6 times I squared is plus 6. These add up to 0. -4 times I squared makes plus 4. 15 and 6 make 21. 9 and 4 make 13. All right, let's talk about complex solutions of quadratic equations. We started with a couple of very simple quadratic equations. Let's move on to some more complicated ones. So you'll recall from before, you learned the quadratic formula for any quadratic equation. And this part underneath the principal square root is called the determinant. And it basically determines whether you get real answers and how many. So if the determinant is positive, you're going to get 2 real answers. What happens if the determinant is equal to 0? We will get 1 real solution. So what do you think happens if the determinant is negative? Well, you have a negative underneath a square root symbol, so we're going to get a complex number. So the determinant is negative, you get 2 complex solutions. Let's try an example. All right, so I think you should try this one on your own. Of course, you try factoring it and it doesn't factor. So try the quadratic formula. A equals 2, B is 2, C is 1. So X is the negative of 2 plus or minus the principal square root of 4 times 2. Oh, I'm sorry. B squared minus 4AC all over 2A. And you can see that the determinant is negative. So we are going to get complex solutions. 4 is a perfect square, but it's negative, so we're going to get 2I. And you can either leave it like that, or if you wanted to, write negative 1/2 plus or minus 1/2 I.